This is our proof of concept platform for the Rio card that we propose to make. What we have here is a Raspberry computer connected to a module that we developed for other projects and that we use to emulate the Rio card. The module includes an octal digital output driver, input conditioners, an RS-232 transceiver, a CANbus transceiver, and a 32-bit ARM Cortex MCU. The differences between the features of this module and the actual Rio card are the board format. The Rio card will be shaped so that it stacks nicely over the Raspberry board. Rio will have a larger 40-pin automotive-grade connector. Rio will have more inputs and outputs. And Rio will have a DC to DC converter for powering itself, the Raspberry, and external sensors. Optionally, the Rio will be fitted with a miniature AHRS module that includes 3-axis magnetometer, gyroscope, accelerometer, and inertial navigation software. The communication between the Rio and the Raspberry is done via the SPI, and for some I/O types, the UART present on the 26-pin header. For this demonstration, we have 4 potentiometers connected to the Rio's analog ports, a switch connected to a digital input, a ping ultrasound distance sensor connected to a pulse input, and 6 LEDs connected to digital outputs. The ping ultrasound sensor is a good example of the sort of I/O processing that can be done by the Rio's MCU. Here, the MCU generates the very special pulsing sequence needed by the sensor and directly produces a distance result in millimeters. Looking at the software on the Raspberry side, we have written a driver and a simple library for reading and writing I/O from a user program using very simple functions. Here is an example application program. We read the analog and ping inputs with a simple Rio read ANA inputs function. The value of the pots and the sensor are then displayed with just a print function. The switch is sensed, and if off, the LEDs display a count pattern using the Rio write all digital outputs function. When the switch is pressed, a steady pattern is flashed. Let's now launch the program. We see on the console the value of the pots, the ping sensor, and the switch. If we adjust the pots, the values change on the screen. By moving an obstacle closer and further from the ping sensor, we see the distance value changing on the screen. The LED is displaying the count pattern. When pressing the switch, we now see the steady flashing pattern. This demonstration shows all the hardware and software components needed to make Rio work. It shows that there are no technical obstacles to move to the next step, making Rio a reality. Thank you for your support.